All right, welcome to MAM339, where we'll be diving into Tipalti's transformation to Windows containers on AWS. I'm joined here today by Maya Freeman, Technical Account Manager with AWS, who was part of the journey, and Lead DevOps Architect for Tipalti, Danny Teller, who joins us today to give us his experience and insights on that journey. And quick question before we kick off today to make sure these headphones are working. Who here is actually running Windows applications, Windows workloads in their environment? Not Windows containers? All right, perfect. How many have actually considered containerizing these applications? All right, so this is going to be a great session because Danny has quite the roadmap coming up here for you, where you'll be able to see all the pitfalls and successes that they've engaged over the last 12 months doing this. So our quick agenda for today, we're going to do a quick background level set on what containers are. Then we're going to dive into Tipalti, their journey, how they got where they are today, the lessons learned, and what's next, what happens after this. And Danny, if you want to let the audience know what they'll be in for over the next 60 minutes, that'd be perfect.
Definitely, thank you, Aidan. So what we're going to do today is we're going to walk through from ancient to modern, all the technical decision making that we had to go through, the challenges we faced, and our performance gains, optimizations, all this fun stuff, some truly weird things, and our results, and finally, how it impacted our business. So stay tuned, fellas. Thank you, Aidan.
Thank you. So we'll see you in a few minutes. So like I mentioned, we just want to level set so everybody's familiar with what Windows containers are, how they come around, and that way, if you're an advanced user or just beginning up, you'll see how easy it is to get started with them. So we're all pretty much familiar with this. Back in the day, one app per server wasn't a great use of the hardware. A lot of high costs, wasn't very, very efficient at all. Next up, as we all know, hypervisors. It virtualized the operating system, the hardware, which is great, but unfortunately, it still wasn't that efficient. You could only run so many hypervisors in one box, and costs, again, are a major component. Lastly, this is where containers really came into its own. Virtualizing the operating system. The benefit this has, you can now have a shared kernel, multiple containers using it, and really optimizing your costs on this. So big takeaway here is your cost, your ability to spin up new systems, be agile, and just be much more efficient in the use of all these resources. So a lot of people forget that the first Docker spec was created about 10 years ago in 2015. So it's a pretty solid solution to go with today. It's not like it's brand new. I know people are familiar with Linux containers, that's what everybody thinks. But fast forward to 2017, that's when Microsoft enabled Linux support on containers. That opened up hybrid strategies. Again, we won't go through every single item, but Containerd came up with Server 2019. 2023, Carpenter support enabled, Amazon supported at the same time, and it's continuing to evolve today. So the big takeaway here is that 10 years later, this is still an evolving process, but it is really a tried and true method for doing Windows containers. Some quick benefits, being agile is one. Being able to spin these up, shut them down, rapid development, that's essential. Cost-wise, we do see customers save about 60% on their EC2 costs, roughly about 68% on their storage costs, and reducing your management overhead. If you are something like EKS, an orchestrator, patching, getting them back, getting them up, failovers, all this, it's a much, much simpler management as well. When we're choosing these, there are some considerations to be brought up. For example, this is 2025. As we go into 2026, if I have a new application today and it's going to use cross-platform.net, I'm going to choose Linux, let's be honest. It's just going to be modern. However, for Windows applications, they're a little bit beefier. So you're going to start off immediately with a 3 gig image, which means that the host has to be larger. So cost is an issue. The size of that image is also an issue. Only certain applications can be used as well to be containerized. And we'll dive into what some of those applications can be as well. We do see across the financial industry, healthcare industry, a lot of use cases in AWS for customers taking their applications on Windows containers. And the types of applications that we do recommend to take would be your ASP.NET, WCF, or Windows Services applications, and finally console applications. Anything that requires a full GUI, absolutely skip that one for right now. these would be your best bet. If it runs on Windows Server today, there's a pretty good chance that you can containerize that application. Now, to get started altogether with this, you only need 5 items. The first item you need is your Docker file. That's your blueprint for your application, has everything in there. The second item here is your proprietary base image. Typically, that's your Windows Server core image that you can just pull down from Microsoft. Third item is your registry to store your images. In this case, we'll say ECR. Fourth, you need your host for worker nodes and so on, which would be EKS. And finally, you need your orchestrator for just failovers, bringing these up, spinning down, all of that. Again, EKS is your friend here. So just these 5 simple items, you are actually off and running with containers. Now, one thing that you can do as well is to speed up the deployment from pulling the actual image to actually starting that off as well, is using what we do is EC2 image builder cache strategy. And how this works is basically you create a custom AMI, and within that you bake in all the components to it through the image builder. And we're going to fly through this. There is a blog that explains this much deeper. You can Google this up online. But essentially by doing this, it does all the work for you up front. So then when you go to launch this, it actually launches about 65% faster than without a caching strategy. And just so you can see this, I've got 2 screenshots here. The top one is using basically a vanilla .NET, ASP.NET application. It is using the image cache strategy. And the advantage of that is, as you can see, pull to pull, it's about 54 seconds. On the bottom, you see the 2 arrows there. We have a pull, and then finally it's pulled and up and working and started. It takes 7x longer. So you can see the image cache strategy does absolutely benefit and gets that launch much quicker for you. I'd mentioned back in 2023, Carpenter, AWS does support Carpenter. It's highly recommended. Works with your kube scheduler, so it automatically spins up nodes as is needed. They'll be cost effective, works with the compute provider. Absolutely something that should be used when you are running Windows containers. This week, you're probably hearing a lot about AWS Transform. We're not going to dive too much into it, but during your modernization journey, what you will be considering doing is also modernizing the code afterwards. The first step is to get it into a container. That way you can modernize without having to do any code adjustments. The follow-up to this would be to use AWS Transform for .NET, point that at your application, and it generally will increase the conversion time about 4x is what we're seeing back from customers today. Like I mentioned, if you want to learn more about Transform, pop by the Expo Center, go down by the Amazon booths. All of them have either VMware and other items that they'll discuss there, code analysis, everything like that for you. And on that note, I'm going to pass you off to the guys from Tipalti here. Maya, Danny, if you want to take it away.
Thank you.
Perfect.
Thank you, Aiden.
Amazing. Thank you, Aiden. So, Danny, tell us what Tipalti is all about.
Well, Tipalti is a finance automation platform powered by AI. And it basically streamlines all your CFO operations. Anything from global payouts, account payables, procurement, tax compliance, treasury, you name it, we've got it. So it actually just makes your life a lot easier. Everything, it's all financial operations, just make it life a lot better. So we distinguish ourselves by combining, by combining a single suite platform with the simplicity and all the complexity you can imagine, just making it simple.
Amazing. Now, let's talk about the technical foundation. Tell us about the application architecture that started this journey.
All right, so picture the early Tipalti days. A .NET 4.7 platform, framework, a monolithic architecture, and a payment platform. And all of that fun stuff was actually hosted on EC2 instances, which is like most monoliths are. And our process was actually multiple processes running all these EC2 instances. You know, fast to develop, reliable, great match for a startup phase.
Well, that's a good setup. Early stage priorities are all about speed and focus, while enterprise scale demands something else entirely. How did that initial success play out?
It played out great. So for initial phase, it was wonderful. Quick releases, stable, reliable in production. It was really fun to work with. But as you expand, all these things kind of hit a small bottleneck. And we quickly outgrew its capabilities.
So you started with a clean, straightforward monolith, served you well at first. What happened when Tipalti began to grow?
When growth happens, it happens fast. And when it does, you need more features, more resilience, and pretty much a lot more of everything. So our single process kind of just evolved to multiple child processes from a single parent. And that's kind of becoming a little complex when all of them suddenly, well, you need to run them. They run on a schedule, and sometimes, they move out after 18 years.
Well, that growth is pretty common. I bet it reduced some serious operational headaches.
Definitely. Headaches is just putting it lightly. Debugging was just a nightmare. Imagine just taking a single process out of these hundreds and just figuring out which one was actually the culprit. Meanwhile, we're still running on EC2 capacity. It was fixed, and we had no scaling. It was truly challenging.
So you had your architectural complexity and infrastructure limitations. When did it start impacting the business?
The turning point was when our hundreds and thousands of transaction volume just exploded into millions. Our systems just struggled to keep up. I mean, we had frequent crashes, delayed payments, slow performance, and most of all, angry engineers. That's not fun, guys.
Well, that's what every scaling company dreads. That the architecture that powered the initial success start holding it back. So what Tipalti experience isn't unique. We see in companies that started as a monolithic a few common pain points. Well, the first is your application was built for a fixed world. You buy a server, you run your application on it. Simple, predictable, until it isn't. You are over-provisioned just to handle peak loads, and you are wasting resources the rest of the time. If you have any capacity spike, there's no elasticity. Your application simply wasn't made for it. And then there's the day-to-day. Your deployment that should take minutes stretch into hours, and you're often flying blind. Troubleshooting feels more like a detective work than engineering. And then there's the point when the monolith becomes the bottleneck. Release cycles slow to a crawl, every component in the system is intertwined, and every bug can ripple through the entire system. If you try to adopt modern DevOps practices like CI/CD, it becomes an uphill battle. The architecture is not built for it. And what really hurts is the business level. The architecture that fueled your initial success simply wasn't built for it. So you are facing with two choices: spend years rewriting or live with the constraint. So Danny, what option did you consider at Tipalti, and how did you arrive to your solution?
We decided that containerization was the right way to go, but then we had a choice. Was it ECS or EKS? Well, we decided on EKS because it felt a lot more natural for us, and we are already heavily invested in it using our Linux workloads. So it was great for us, and then also it addressed the scalability challenge far better. And finally, we needed machine access because, well, let's face it, sometimes Windows, you need to understand the intricacies of the stuff. So we needed that access. And finally, Windows and Kubernetes is kind of the uncharted territory. So that was fun to go with.
Where did the confidence come from?
Absolutely from our DevOps team. Those guys are relentless. They just tore into that stuff, and they just really remodeled the entire thing. So, and also, the container ecosystem was very mature, so it helped out. So it was great. And we decided on a minimal risk approach. We wanted to stay as close as we can so we could focus on the application instead of the platform. So EKS was naturally the perfect fit for us.
So basically, when you're ready to containerize your Windows application, you get to a fork in the road. Do you go with Amazon Elastic Kubernetes Service, EKS, or Amazon Elastic Container Service, ECS? And let me just go over both and explain what each offers so you will know why Tipalti made their choice. So let's start with Amazon ECS. Think of it as as AWS knows best approach. We've taken hard-won lesson from running containers at massive scale and baked everything right into the service. And the good thing is that you don't have to become an orchestration specialist overnight. ECS is opinionated in the best way. And it's relevant for team who wants to focus more on their application and less on the infrastructure. Now, EKS tells a different story. This is for team who want the full power of Kubernetes experience. Or maybe for teams like Tipalti who are already running Kubernetes on other workloads. You are getting the same experience everywhere. So how do you choose? Basically, it comes down to your team's DNA and where do you want to spend your energy. ECS focus on the application and less on the infrastructure, while EKS offers you that Kubernetes flexibility, or when you're standardizing across environment is part of your strategy. And the good thing is that both are 100% ready for Windows production workloads. So the question is not which one works better, it's which one fits your team's strategy. So it comes down to control versus simplicity, and Tipalti chose because of their extensive DevOps expertise and their need for deep debugging of their environment. Now, when it comes to .NET application on AWS, this flow chart is here to help make the decision. How do we move? So it's kind of prescriptive and it requires some investigation and deep dive, but eventually there are 3 migration paths corresponding to those paths. So the first one is rehost, okay? It's simply moving your application as is to traditional servers like Amazon EC2 instances. The second, which is a re-platform, is making some changes to your application to accommodate the underlying platform compute changes, like moving to run on Windows containers. And the third one is refactor, which is re-architecting your application. This pattern helps you to use cloud-native solutions such as serverless or porting your .NET framework application to cross-platform .NET and run on Linux container. And finally, this is the path Tipalti chose. They were already running on Amazon EC2 instances, and they decided not to spend years rewriting their code base and to move to run on Windows containers. Now, Danny, let's dive into the nuts and bolts. Walk us through what it took to get your Windows container running on EKS.
So first of all, we read every single AWS doc that mentioned Windows and Kubernetes in the same breath. And we found out there are a couple of key nuances that you have to set up right from the start. Now, if you don't do that, you're probably not going to have a smooth sailing in the process. So.
Okay, so once you had the lay of the land, what were those setup steps?
Well, the first one is actually setting up your VPC CNI. And that's the actual component that's responsible to handing out IP addresses to your pods and tying it to your VPC. So we had to tweak it with the right flag, as you can see, and it was very straightforward. However, unlike Linux nodes, Windows nodes don't run the AWS node pod that actually does the tying for your IP address to your VPC. That actually happens internally, and that's a fact we had to really pay attention to going later on. Next, we had to tweak in the AWS IAM permissions specifically for Windows nodes. It has a small addition to Linux nodes, so we had to tweak that as well. And that actually used to live in AWS auth config, which is now conveniently replaced with access entries.
Okay, so once the foundation was in place, how did you decide which Windows container or which Windows version or which container setup you want to use?
We decided to stay as close to home as we could, so we decided with Windows Containers Server Core 2019 running on Windows Server 2019 server nodes. Right? Very identical, very close to home. At some point, we actually tried to match the OS build of Windows, but that proved to be very, very tricky, so we stuck to LTSC versions, and it was very, very simple for us to do that.
Okay, so that's a pragmatic approach, especially for business critical workloads. So compatibility can make or break a deployment. So what drove this level of caution?
It was about risk reduction. So this is a payment platform, zero tolerance for downtime or any interruption. So we wanted to stay as close and identical to something we already knew was running. And by moving to the same setup on Kubernetes, we were actually able to reduce operating system overheads. So it played out well for us. But it's only part of the trick. Sometimes you have to pay attention to what Windows images you're going to choose.
You're right. So Microsoft offers 4 container-based images, which each one exposing different Windows API set, this is what influence on the final container image size and on-disk footprint. So let's start with the minimalistical dream, Nano Server. This image exposes just enough Windows API to run a cross-platform .NET or modern open source frameworks. So it's excellent for building sidecar containers or when every megabyte matters in your deployment. It's lean, it's fast, and it gets the job done. The next is Server Core, and there's a reason this is the crowd favorite. This one strikes the sweet spot between efficiency and functionality. It exposed those Windows API sets that support .NET Framework and those bread and butter Windows Server features like IIS. And it covers the majority of enterprise application needs without going overboard. Well, the next one is a server. It's a little smaller than the full Windows image, but don't let that fool you. It packs the complete Windows API set. It makes it perfect for applications needing to run DirectX graphic capabilities. It's like having a compact car with a surprisingly powerful engine under the hood. And the last one, the heavyweight champion, is the full Windows image. It exposes every single Windows API you can think of. It's massive, but if you need to run a graphic-intensive application or cutting-edge machine learning framework, this is your go-to. So when you come to choose, you need to consider everything you bring along with you. Those ODBC driver, your application calls, or those specific APIs you need to run. If you go too small, your application won't run. And if you go too big, you're hauling around unnecessary weight, it will slow down your deployments. So then at this point, your EKS was configured and ready, and what were the next steps?
Well, the first step is encountering our significant first blocker.
Okay, let's talk about those blockers.
That's really fun stuff, you know. So the first challenge was about logging. But, you know, launching a container is usually the easy part, and debugging why it's misbehaving is actually, well, the most interesting part about containers. So picture this, that you're running on, Picture this, that you're running on an EC2 machine, and what you'd usually use is an XML format, which is standard, reliable, and you'd install a Fluentbit agent, and you'd get those logs right into your logging system, which is very easy, very fun to do. But when you go into Kubernetes, Windows, and you need JSON format, all that goes out the window. That's not going to work that easy. So what you're actually going to do is you're faced with a couple of choices. Do you bake the agent into the Docker file? Do you run a sidecar? Do you look for a vendor to solve it for you? Or do you rewrite the application completely? Just for the logs, right?
So here's where Windows containers throw you a curveball that sometimes catches teams off guard. In the Linux world, logging is beautifully simple. Your application, your containerized application dumps everything to standard out. The container runtime catches it, and boom, you have logs flying. It works every time. Now, in the Windows world, pods don't generate standard out by default. Okay? And here comes a solution that's called Log Monitor. Think of it as a universal translator for your Windows login. It formats everything from ETW, from your Windows event log and your application-specific logs, and it formats everything and pipes it to standard out, something that Linux does by default. It's like a bridge between the two worlds. So how to set up it? It's pretty simple. You take Log Monitor, you integrate it into your Windows AMI during the build. You configure your log specification as part of in your pod. You deploy a log forwarder, like a Fluentbit, and configure it to send everything onwards to hopefully CloudWatch. So as Danny mentioned, I will share something from experience. So formatting is very important. Always log in a structured format like JSON or syslog, because you will be very grateful if you're debugging at 2 a.m. and you have logs that you can parse. And second thing, less is more when it comes to verbosity. Keep it quiet unless you are actively debugging. Important event can get lost in the noise. So this is the technical. How did it actually play out?
Well, we started off with Log Monitor, just as you mentioned. And once we plugged it in, we actually saw logs. It was great. Worked really well. So we actually were able to see our logs within our system. And it played out pretty well. And it actually confirmed for us that we were able to see a Windows container with a legacy application and logs flowing through our system. It was good.
So seeing it process live logic was kind of pressing, I'm guessing. So did Log Monitor stay in your configuration for a long time?
Initially it did, until it didn't. Because we actually found out that Log Monitor introduced some unwanted baggage and overhead. It kind of made the application crash sometimes. It crashed on its own. It wasn't very fun to hear and look, of course. And one of the things about it is when you hook one process into another, it's bound to have some mysterious activity in it, so it's not very effective. So what we actually did, we modified our application logging configuration to log directly to standard out and actually just solve the problem for us. And once we did that, we had logging flowing into our centralized logging system, and the first challenge just marked as completed. So that was good to go.
So once this hurdle was behind you, what came next in the road to production readiness?
Our next challenge was a completely different set of difficulties, something completely unexpected. So we were testing various application versions. It was great until we stumbled upon something really, really nasty. I mean, what happened was we would roll out a new version and we saw pod getting stuck in terminating state for quite a long time. I mean, like 5 minutes or something, depending on your configuration. But they were just stuck there instead of just terminating as they should.
So first of all, that sounds very frustrating. Can you tell me what was happening under the hood?
Yes. So we actually suspected something between the kubelet and containerd. So in a nutshell, once you shut down a container, kubelet actually sends that signal to the container, executes any pre-stop hooks along the way, and then the container actually shuts down and reports back to kubelet that it's gracefully shut down, having fun. But actually, for us, it wasn't really happening because you see, in Linux, you have the sig term, and in Windows, you have something different, an equivalent of that, which at that point wasn't really propagating properly. So we had to really investigate to understand what was going on.
So Kubernetes was doing its job, but the signal was not what the application was expecting.
Yes, so our application was actually coded to handle that specific Windows event for shutdown just fine. But Kubernetes tried to send that signal and nothing was happening. So we figured along those lines that something was going on. So that stuck period, we're actually Kubernetes force killing the pod using the graceful termination period. So it was stopping, but not gracefully. Very brutally, in fact.
So what were you trying to do to pinpoint the root cause?
Well, we dug in. Well, you have to. So we actually found there was a bug in the containerd. At the time, AWS was running 2 different versions for AWS Linux and for Windows. And for Windows, they were running version 166. And apparently in that version, a signal propagation for Windows was not supported. So that's why it wasn't working.
Okay, so this is where Windows diverges from Linux again. As Danny said, Kubernetes sends a SIG-term signal that the Windows runtime translates to something called control shutdown, which is the Windows native event. If your Windows application receives the event, it will just behave normally and shut down the application. But the translation is very crucial because Windows applications are built to respond only to control shutdown event and not to SIG-term. So the container runtime acts as a bridge between the Kubernetes world and the Windows world. So how did you work with AWS to handle the gap?
Well, we reached out to AWS through GitHub, so it was a great collaboration. We opened an issue and somebody replied. Very straightforward, it was very quick to do. And they confirmed that a later release fixing that issue, just upgrading a version, was coming later that year. But unfortunately for us, we can't wait. We have to solve these things right here and right now.
So you found a workaround?
Of course we did. What we did, we relied on Kubernetes native features. We introduced the lifecycle hooks we mentioned earlier, and we tuned in our graceful termination period. So we had more control over when our application was shutting down and how it was shutting down. So it played out well for us. So all we had to do was just sit back and wait till AWS released the newer containerd version, and we're set to go.
Okay. So once that was behind you and everything was up and running, how did you validate that the containerd version was behaving as expected?
We decided on the ultimate head-to-head battle. So we compared our EC2 environment to our Kubernetes environment. So they're running side by side, same configuration, same environment, and they were both plugged into the same RabbitMQ. And what we saw was a mysterious new client just consuming these messages, making our developers actually coming over and saying, what is this new container doing? What is this new agent that's consuming our messages? And of course, it was our Windows pod just pulling its own weight.
So another thing very satisfying to watch.
Definitely. Finally, we could actually see our container, Windows container, working properly on real business live logic, and it was really great to see. So what we did next, we bulletproofed everything. We touched performance, we touched the baseline, we continued with testing, and then we're very eager to start the next phase.
Okay, so now you are ready to test the core promise of cloud-native transformation, scalability.
Definitely. This is the moment we've been waiting for completely because we wanted to test scalability. So what we did, we of course plugged in our Windows pods and we tuned them to listen to messages on RabbitMQ using Keda, or Keda as you prefer. And because we wanted to actually scale based on amount of work to be done instead of just server load, CPU or memory, which is classic but not enough. Well, not today anyway. And finally, the other half of the battle is infrastructure. You can't scale an application if your infrastructure doesn't support it. And since we were on Kubernetes and we're already using Carpenter, all we had to do was just extend it by just another CRD.
So what kind of result did you see when you tested the scalability?
A great kind of results, scaling results. We were actually able to see our pods and our Windows nodes scaling up and down very seamlessly and efficiently. So that was a really great turning point for us. We enjoyed that spectacle.
Okay, so this is a huge shift from the old model. So beyond the scalability itself, what other improvements did you notice?
We noticed that by running the EC2 and the Kubernetes equivalent side by side, we actually got a 50% improvement boost. That was completely unexpected. It wasn't just running, scaling better, it was just actually more efficient in how it was working.
And from operational perspective?
That was a real game changer because at that point, instead of just debugging hundreds of processes, we had a single pod with its own process, and we could see logs, traces, metrics. It was just beautiful, super simple, very straightforward.
So, Carpenter is AWS native. It understands things like spot pricing and EC2 commitments. So it can help you not just scale up, also to scale down, to consolidate workloads, and turn and shut down nodes. So if we're speaking of costs, let's talk about it because I think this is something that will interest a lot of people. Going to a full-blown Kubernetes cluster running Windows must have its financial trade-offs.
Definitely. I'll be honest about it because our infrastructure and our costs kind of spiked up a little bit, but not by much, on a good note. But it was actually very, very worth it.
How did you justify such additional costs?
Well, the operations actually weigh out the spend. We got a 50% boost, we got scalability, and ease of deployment. I mean, all these things, when you factor in together, they kind of justify this extra spend, right? So while our server bill actually did spike a little bit, factoring our total cost, all the pain and suffering we've kind of alleviated from our developers and customers was just worth it.
Still, every smart company looks for optimization opportunities. What strategies are you exploring, to keep the cost in check?
Well, we tried spot instances, but unfortunately our application couldn't handle the shutdown event for 2 minutes with a notice for spot instances, so that was out the window. Instead, we relied on savings plans and reserved instances. For right sizing, we used EC2 Compute Optimizer, and finally, we traced our resource usage using AWS Container Insights to right size our actual pod usage. And as you know, the cost efficiency battle and the performance battle never ends. It's an ongoing session.
You're right. It never ends. Just another insight. It's very important to use Cost Explorer. There is a feature, there is an option to enable cost allocation, split cost allocation data, also known as CAD, and you can also leverage cloud intelligent dashboards to monitor your container costs. You can set up budgets, you can set up alerts to let you know if you have a cost spike unexpectedly. And as Danny said, the key insight is that cost optimization is a journey. It's not a one-time activity, and you need to always have it in the back of your mind. So what's the long-term impact?
Overall, it's an absolute win. We were able to cut down on manual operations, on response times and debugging, and best of all, we're actually able to eliminate the infrastructure and bottleneck we had for scalability. And that kind of thing is priceless, no matter how you try to go around it.
Okay, so now everything is stable again. What area did you focus on improving next?
We decided to focus on 2 key areas. One of them being the node creation time and the image pull duration. And if you break it down, then node provisioning actually takes around 7 minutes from EC2 creation to joining the Kubernetes cluster. And images were actually about 4 minutes just to pull.
Okay, so let's focus on the nodes first. 7 minutes is noticeable.
Yeah, so definitely noticeable. And we dug in, and we saw, of course, that EBS configuration was actually the culprit for the entire thing. So as you know, the baseline when you create an EC2 machine, you get 125 megabytes of throughput with IOPS around 3,000. That's great for general workloads, normal EC2 machines running, that's fine. But when you're talking about Windows and you want to go faster, that's not enough because Windows needs more bootstrapping time and processing. So we did the natural thing. We doubled all the values. And actually, it shaved off around a minute, even more. So from 7 minutes, we cut down to 6, and sometimes even lower than that. And we tried going different directions and trying to explore different values, but that was in vain unless you're willing to go the extra spend and try using IO1 volumes, which are, well, you know, very expensive and blazing fast.
Okay, so that's a fair trade-off eventually. And the second bottleneck, the container images, I imagine that around 4 gigabytes of container image is not exactly zippy.
No. So our actual image containers, they weight around 4.5 when you take in the baseline image and the application itself. So it turned out to be around 4.5. And when you start pulling it out, then it kind of takes a long time. And if you compare it to Linux, then it's massive. 4.5 gigs over to what, 100 megs on a Linux machine? That's fairly massive.
So what did you do? Did you change the image structure, or was it something from the AWS side?
Actually, it was a bit of both. We noticed that at some point, AWS started preloading base images onto their EKS optimized AMIs. So after a few AMI version changes, we noticed that it was a quiet change, and it dropped down from 4 minutes to around 50 seconds. It was great, yeah, pretty much, but we were not satisfied. We introduced an internal image registry. And by doing so, we were actually able to cut down from 50 seconds to 20 seconds. And they're just very fast.
That's a very dramatic improvement. So what kind of overall impact the optimization had?
By combining both results, we were able to slash the times from 11 and a half minutes to around 6, sometimes even less. 6:30 was being the average. And it actually made all our deployments feel very responsive, very snappy. So it was one of those moments when you invest all this time fine-tuning and actually does pay off.
Okay, so things were smooth by then, right? Production was stable?
At that point, yeah, we were pretty stable. We were running with 4 Windows nodes, scaling up and down with 35 Windows pods, with being more services added every day. It was great to look at. And we're actually still running with 50% improved performance boost, and our deployments are around 6.5 minutes. But the best of all, the dramatic reduction in incident response time and all the incidents was just blowing us out of the water.
Okay, and what about your team's operations day to day?
Well, they shifted from actually firefighting all the time to, you know, innovating, writing new features, rewriting, refactoring even a bit of the code.
Oh, nice. But it wasn't the end, right?
No. Unfortunately, that was not the end. We actually, well, it was a bad ending, I have to say. So at this point, we were after the containerd saga. It was a very difficult time, and then we were finally kind of stable. But at some point, we noticed that when we started rolling new versions, the pods really refused to die. You try to force delete them, they'd still be there. No termination grace period could help, nothing. They were just stuck there. At some point, we started calling them zombies.
I don't know what about you, but I don't like zombies. Okay, so I'm guessing it was very frustrating. How do you begin to hunt it down?
Well, we spent 6 weeks debugging with AWS support team on this. We'd every time get a new theory, understand, see if it can work, test it out. Now, of course not. And we're just really pulling our hair at this point. So we're just hunting it down and nothing worked.
So 6 weeks to hunt is a long time. What did the investigation finally turn up?
Well, actually, it was a critical regression bug at the platform level. It was one of those Windows services, the host networking service, which is actually responsible for networking, that we have zero visibility into.
So a black box bug.
Yes, definitely a black box bug.
So can you walk me through the technical details of what was actually happening?
Yes, it turned out to be a nasty, really nasty race condition. When one pod was starting and one was actually shutting down, it was causing the networking component to actually create two dual endpoints. So at one point you had a living pod and a dead pod, kind of, Schrodinger's pods, if you say. And that was kind of very difficult to understand how it was working, but we were able to understand and find it.
Okay, so what did the AWS do?
Well, as we were working with AWS, they decided to, of course, go into the networking components. They tore them out completely and traced the bug to a recent platform change. And they fixed it at the AMI level, and they, of course, coordinated with us.
Okay, so, but a platform level fix is not something that is immediate. It takes time. So how did you, how did you do in the meantime? What did you, when you waited for the actual AMI to be released?
We got a little creative, so we were using a Carpenter feature to introduce a TTL, time to live, on our nodes. So we kind of paved over the problem by refreshing the nodes every 3 hours, meant clearing the bad networking state entirely. And we also introduced some manual and automated procedures, to exercise those demons. And finally, we added alerts just to catch them just enough or even before it actually happens. So we could actually tell when's it going to happen.
Okay, and the final resolution, did the AMI do the trick?
Definitely. When AWS released that AMI fixed, we immediately implemented it, and it fixed everything. So we were actually back to reliable production. Everything was stable, smooth sailing from then.
Okay.
And it was also a challenging time for us as well. We were working hard with AWS, and it kind of strengthened our partnership deeper.
That's always good to hear. So let's zoom out for a minute. Can you tell me, after all this work, what did this transformation actually achieve for Tipalti?
Yes, so definitely our results, we had a 50% performance boost constantly across the board. When comparing EC2 to Kubernetes, our scalability just changed completely. From 6 hours from creating a machine and installing and everything to just a pod running everything. It went from 6 hours to 6 minutes. That's incredible on its own. And also just the installation and running the pod and the service itself, from running on 4-minute installation to just 30 seconds on a Helm chart deployment. That's a massive improvement for us.
And how did life change for the team?
For the better, of course. So we went from 12-hour debugging sessions to just 2 because we had clear observable telemetry for logs, traces, and metrics from a single pod process instead of just hundreds of millions of multiple sub-processes.
Okay, and from the business side?
Well, we achieved something that was pretty impossible for us early on. We had no horizontal scaling, and we actually were able to solve that using this transition. So the business impact was just incredible for us. And we employed, of course, it opened the door for many modern DevOps practices, so we can just employ them and continue innovating our procedures.
Okay. And when you look back on all this journey, zombie pods and all, what are the key lessons learned you will share with people thinking about a similar transformation?
Well, I'll break it down into a few key areas that we actually learned the hard way. So on a technical perspective, you got to start with small changes. Okay, you have to test it out first, understand if you can do that. And by doing so, you can preserve your existing .NET framework and get modern benefits all the time. So, and kind of, when you're working with Windows, just expect some unexpected things. It's kind of a cliche to say, but Windows is always behaving like it does. And from operations perspective, engage AWS proactively. It saved us so much time if we would have done that a lot earlier. And most of all, document everything. We documented every single process and every single execution that we did, just so we have enough information to go on. Strategically, incremental modernization works. It works 100% of the time. You don't need to rewrite your application from scratch. You can just start small. And from a crisis management point, the Schrodinger's pods actually taught us to be a lot more proactive. And by doing so, we're actually able to overcome all these issues that we faced. So comprehensive monitoring definitely is a must, especially for these types of things. And you should also have mitigation strategies. Don't just blindly go into something. You have to think some sort of way for the unexpected issues.
So there are four critical factors that usually contribute to a successful transformation. So the first one is executive support, and I don't just mean someone writing off on the check. Executive support means management understanding that this is not just an IT project, okay? It's a business transformation, and one of the biggest transformation killers is organizational silos. Solutions that works on perfectly in isolation often fail in organizational reality. So it's very important to create transformation teams with developers, operations, security, business stakeholders, people who have a real decision-making authority. And I'm guessing that if you want to containerize, you want to do it yesterday. But this is not a race. It's like you don't want to migrate during peak hours. You need to take it easy, to start with non-critical workloads, learn from experience, leave enough time for testing, for troubleshooting, and for the unexpected. And last, container technology is always evolving. Successful teams build learning into their DNA. Not just initial training, but an ongoing education program, feedback loops. Best teams leverage support proactively, using expertise to optimize architecture and always stay ahead of best practices, not just fix problems. And now, Danny, what's next for Tipalti?
Well, the improvement game never stops. So we're going to continue exploring how we can make everything much faster, from node provisioning to image pulls, because we want to be as close to Linux speed as possible. Next, we're going to be working on more cost optimizations because, like I mentioned, this never ends and you want to save as much as you can. So we're going to be heading that direction as well. We're also going to be tuning in our for our scaling policies. So they're going to be better scaling for us as well, more proactive. And all this endeavor actually created a great foundation for our microservices, so we can port legacy applications onto microservices without a pressure of a complete rewrite.
And what about your broader technology strategy?
Well, GitOps. GitOps is the best. So what we're going to do is we're going to implement more GitOps workflows, and well, by doing so, we can actually work with better and more modern DevOps applications and practices. So that's not going to end anytime soon.
Okay. And so let me just say that that's a great example of what Tipalti did, that a successful transformation can enable broader modernizational effort. The containerization is not the end goal, but it helps set the foundations on continuous modernization. And that's the real value of this approach. If you want to continue your containerization journey, there are some resources we put here to help. You have the Windows container on AWS Immersion Day, best practices for Windows on Amazon EKS, and check out Windows container in Kubernetes. Take a picture, scan the QR, and go check it out. And in addition, beyond that, if you don't know, we have AWS Skill Builder, which is your gateway to mastering all things AWS cloud technology. There are over 1,000 free, self-pacing, expert-led courses. You can follow guided journeys or just jump directly to the topics that interest you. And with that, thank you very much for being here today. feel free to reach out and stay tuned because the blog post on this journey is in the making.
Thank you.